For today's webinar, we're going to be looking at really developing functional safety management plans and specifically how templates can be used to really improve that process and support going through and having a effective functional safety management. Before jumping into our topic, I want to just give a brief background on myself. My name is Patrick O'Brien. I'm a safety and cybersecurity engineer with Exida. My background is in chemical engineering, and so through that, I've done a lot of work from process hazard analysis through layer of protection analysis, SIL determination, all the way through SIL verification. On the safety side, and then I also do consulting on our cybersecurity side, so kind of looking at then the network side of things and how attackers can come in and start to cause some of those similar consequences. And so that just gives kind of a brief background on my experience at Exida. Exida is a customer-focused company, and really our goal is to help customers achieve safe and reliable solutions. And we do that in three ways. The first is our enterprise tools, so most commonly thought of as our Excellentia suite. So really having that consistency and the ability to efficiently deliver technically correct results. We have certification and assessment, so documenting compliance through a pragmatic approach to IEC 61508 and IEC 61511, as well as to cybersecurity and then also automotive and machine safety application standards. And then lastly, we have our lifecycle services. So this is then really working directly with the end users on projects and going through some of those safety lifecycle activities, again, to kind of solve the toughest functional safety problems. Exida does have a global focus. We've got offices all around the globe working really across every industry. So we like to say if you have a question or problem with functional safety, we like to think that we're the people that can help with that. For today's webinar, we're going to kind of go through in three main steps. The first will be to look at some trends that we're seeing in the adoption of functional safety, and really try to capture what we're seeing in the marketplace, what some of the typical gaps that we're seeing when people implement functional safety, and then some of the potential solutions to those gaps. And that'll really be where we look at functional safety management coming into play, and seeing how that will function together with the other aspects of the functional safety lifecycle. And then lastly, we'll look at really how templates can be used and what the benefits of starting with them to develop the functional safety management plan. So to get started, if we think about what are the different forces at play that lead to the adoption of functional safety, the first one that we can think of are the national standards and regulation. And so if you think about the United States, we have OSHA PSM and requirements for providing a safe work environment. And again, this does not say specifically require the IEC 61511 standard or any standard for that mean, but it requires that companies demonstrate that they're following industry best practice. And so the IEC 61511 standard is called out as one way of demonstrating that you're meeting best practice. For some countries in Europe and also across the globe, it's more explicitly required, and so the health and safety executive in the UK explicitly documents that meeting requirements of IEC 61511 is one way to meet the requirements for providing that safe work environment. And so if we think of standards and regulation and those associated audits as one potential driving factor for the adoption of functional safety, another key adoption is also these insurance requirements. And so especially in the US and other countries where it maybe does not have the weight of law to follow these relevant international standards, insurance companies will actually come in and look for this documentation. And we've seen that kind of play out on both ends. On the one hand, if you're not able to demonstrate that you're meeting functional safety requirements, that you have clear documentation, that you're completing the different life cycle tests, we've actually seen insurance companies either threaten to remove, to no longer insure companies, or actually pull their insurance if they don't feel that functional safety is being applied. And from their point of view, trying to insure an operating facility that doesn't have good safety is a bad investment. kind of on the flip side, we've also seen companies get a premium reduction if they have very clear documentation and they're showing that they're meeting not just functional safety, but also well-defined alarm management, cybersecurity, that they really have all of that documentation in place to kind of get a preferred status from the insurer. And so a combination of that insurance requirements and also the regulatory requirements really are some of the big drivers leading facility risk management. Additionally, we're seeing application standards, and so when we're talking about this is functional safety applied to a more specific industry. So if we think about process industry, that would be our IEC 61511 standard. For automotive, it's ISO 26262. There's also IEC 62061 for machine safety, specific application standards for nuclear. So all of these really give a more specific set of requirements for that individual industry to support facility risk management. And then the last force influencing the adoption of functional safety is really the stakeholder expectations. So the specific companies' own policies, their requirements for meeting their overall safety objectives, as well as when working on bigger projects, the individual stakeholders will all have their tolerable risks, will have really what their approach is for maintaining safety. And at the end of the day, having a comprehensive facility risk management approach is becoming an expectation. And so for all of these factors, we're really seeing a push towards overall facility risk management. When we look at that, we then say, well, why is there a need for this standard? And it comes down to three simple points. The first is to provide a safer working environment for people. So this really comes down to saving lives and continuing to improve the safety within the process industry. And time again, when we see these major accidents, it's not just one individual failure. It typically comes from a compounding of a number of different factors. But one of the big problems overall would be, say, a poor safety culture or not having the documentation to be able to have clear traceability. And so one of the needs for this standard is to really provide that framework to improve the overall safety. Additionally, it's really to protect the investments in plant and equipment and to ensure continuous operations. And so from that side of things, it's also providing a financial benefit. Because when you go through and put all of the money and time it takes to go in and develop these operating systems, the expectation is that you're going to be able to have continuous operations to make a return on that investment. And so having a well-defined safety system that will prevent these significant incidents from occurring also leads to significant savings in money. And then lastly, to demonstrate compliance with the regulatory requirements, and that also provides a financial benefit by avoiding fines. So if that is kind of our need for the standard, the next question is, well, how could a standard help with this? And so the first aspect is really providing a clear documentation of industry best practice. It's a way to demonstrate that you're going ahead and meeting what the expectation is for the industry, and also can show where you go above and beyond and are exceeding what's typically seen. And so there's a clear way to really benchmark against and have an understanding of what that best practice is. It also leads to consistency across organizations. So having clear requirements for equipment manufacturers, system integrators, the end user, owner-operators, and also the engineering, procurement, and construction firms really helps to ensure that none of the requirements fall through the gaps. And so on these big projects, where there are 5 different vendors for a specific package, and then you've got a total of 7 or 8 different engineering firms putting these packages together, having a clear and consistent set of safety requirements between all of these organizations is really fundamental to making sure that you're achieving the overall objectives of safety and continuous operation for the facility. And specifically, the standard can do this by making it less likely to miss a key step, because there's this step-by-step method. So you can see all of the key requirements that need to be gone through and met. And also, common or known mistakes are then explicitly addressed within the standard. And so having this makes it a lot easier to follow a consistent process and achieve the desired end result. And so The outline that the IEC 61511 standard provides for this is the safety life cycle. And essentially, it's documenting the key activities all the way from the analysis to identifying what process hazards are present within the system, identifying what the independent layers of protection are, and specifying really what the requirements are. So it covers that analysis phase, but then also going through design and implementation, so looking at the actual design of the safety systems, the factory acceptance testing, installation and commissioning, all the way through validation. So making sure that not only you've really understood the concepts, that you've developed the right systems, but that you've built, tested, and installed them correctly. And then finally going on to the operation and maintenance phase. So ensuring that the necessary proof tests, that any changes to the safety system are well managed, and then when parts are decommissioned, that you go through and follow that set procedure. So all of these are really the key steps in achieving functional safety throughout the life cycle of the facility. And so in addition to providing kind of the key requirements for each step, the standard also identifies functional safety management and also some functional safety assessments. And this is really key across the entire life cycle because it provides those overall requirements for documentation, personnel competency, roles and responsibilities, so that when you get to each step within the life cycle, you know who's responsible for it, what the general requirements that they're going to follow are, in addition to the specific requirements of that task. So the functional safety management plan is really what brings it all together and allows for a consistent process for going through and meeting the requirements of each step. Additionally, it'll document the requirements for functional safety assessments. And so the standard calls out 5 assessments that are performed throughout the life cycle. And these are really meant to provide an independent check of the work and make sure that all of the previous steps have been done correctly before going on and doing the next step. And so this is really key for trying to avoid surprises later, and they end up kind of helping the project run more smoothly and avoiding bigger issues down the line. I think the one kind of perfect example for this was in a subsea application. They had not done the earlier FSAs 1 or 2, which are optional in the standard, and then so they had designed the safety system, they had installed it under the sea, and they got to FSA 3 and went to test it before startup, and it didn't work. And so it turned out that I think it was that the final element had been wired incorrectly. So when you hit the push button to open it, it essentially was just staying closed. And so something that would have been easily identified had they done one of those earlier checks turned into a multi-million-dollar incident, and then they had to then go through the whole thing, design another system, and bring that down to the bottom of the ocean. So that's where kind of following through with the overall functional safety management and doing those functional safety assessments periodically can help to avoid bigger problems down the line. When we talk about effective implementation of the standard and really how to get the best results from using the functional safety lifecycle, we typically recommend starting with a benchmark. And so that will be going through and kind of documenting where you stand to each requirement in the standard and getting an understanding of what your strong suits are, what areas is there potentially a need for more focus. From the results of that benchmark, we can develop a functional safety roadmap. And so, if we think of it as our treasure map, it's kind of figuring out what needs to be done to then reach that idea of your overall facility risk management, meet your tolerable risk criteria, ensuring that you have the different pieces in place to do that. So once the roadmap's in place, kind of the key document is our overall functional safety management plan. So having those high-level requirements relating to the people, paperwork, and procedures that are going to be needed for each lifecycle task is really fundamental to the effective rollout. And then lastly, understanding the individual steps from really each of the life cycles. So from system design to implementation and then operation and maintenance. Once you have everything in place, going through and actually carrying out the life cycle for those key activities. When we talk about the benchmark, really we're going through and focusing on all of the key requirements outlined in IEC 62511. So we start by talking about the overall safety management. We go through and look at then how the safety life cycle is addressed. And we also look at kind of what's done for the individual stages of the life cycle. So what the risk assessment procedures are, what the tolerable risk criteria are used, what's done for SIL selection, whether it's layer of protection analysis or another more qualitative method, the requirements for the safety requirement specification, how the safety intermittent systems are really specified so that there's clear traceability of the requirements, the design of the safety of the SIS, going through in the process for SIL verification, what's required, everything from the SIS application program design and the SIS application verification. So not only having clear documented requirements for the instrumentation, but also for the application programming that's run on that equipment, and ensuring that you don't have the potential for any dangerous failures that have been introduced based on the application program the controllers are running. Also looking at factory acceptance tests, so the way through the installation, commissioning, validation, all of the steps of really implementing the safety system, as well as then the requirements for the SIS operation and maintenance, so what the proof testing is, how that's carried out, the management of change, so looking at SIS modification, decommissioning, the SIS documentation, so having clear traceability of all of those requirements and the outputs of each step. And then also in the latest version of IEC 62511, it specifically calls out cybersecurity in a couple of sections, one of which is saying that for the safety instrumented system, a cyber risk assessment has to be completed. And so that update to the standard is really recognizing that functional safety and cybersecurity are becoming more and more closely tied, because if you can't ensure that your safeguards aren't vulnerable to a cyber attack, then you don't necessarily know that they're going to be as reliable as needed. And so understanding kind of the high-level approach to cybersecurity and also alarm management are now playing a more and more important role in the adoption and also implementation of functional safety. And so for alarm management, we think of when we go through and do our layer of protection analysis or our SIL selection, if we're claiming an alarm layer of protection, there are specific requirements. So understanding the operator has sufficient time to respond to the alarm, making sure they have clear procedures so that when they do get the alarm, they can do the correct action to prevent our consequence from occurring. All of this is really fundamental to making sure that when we've gone through and done our safety analysis, that we've have the correct really protections in place and that we're not being overly optimistic in our analysis. So those are kind of the overall areas for the benchmark study. If you look at a sample of that study, this is pulled from the safety management section, and we've got 3 of the requirements just pulled out here to look at. But the first one is the requirement that a functional safety management plan exists to really guarantee the correct SIS functionality, cover the safety policy, the actions that are taken to achieve safety within the life cycle framework, and also the procedures done for each of those life cycle tests. And so really we're looking at the overall functional safety management plan for the entire life cycle and understanding what's done to document that. The next column then covers what part of the IEC 62511 standard is referenced so that you can easily cross-reference the requirements as they're written in the standard with our safety case requirements. And then the compliance argument. So an example compliance argument for the FSMP might be kind of referencing the functional safety management plan that's used, showing how it fits together for each step, and document then that traceability from the procedures, the planning, and then the actual execution of those life cycle activities. And so for each of those categories listed on the last page, we have a number of questions and requirements that we then go through and document what's currently done. And so, through doing a number of these benchmark studies, whether it's as part of an IEC 62511 certification or also maybe a less formal gap assessment that would be done just from the end user consulting side, we've noticed a couple trends and typical gaps that we see when implementing functional safety. And so the main gaps that we often find are no structured process. And so the organizations may be doing the right things, whether they have good risk assessments that they go through and do. They're picking SIL targets and then doing verification to that. But even though they're doing some of the bits and pieces, they don't have a formal structured process in place that says when they're going to perform those activities, who's responsible, what the specific documentation requirements are. And so that really makes it more difficult to, if you have either the insurance company coming in or also a regulatory compliance audit, you're not able to necessarily clearly show that you're meeting industry best practice, and even though you're doing the right things, you don't necessarily have the traceability to demonstrate that. Another thing we see is sometimes there's no formally agreed upon tolerable risk. So even though the organizations may be performing different types of risk assessments, there's not a clear understanding of what the tolerable risk guidelines are, and so it may be a more fully qualitative method that such as brainstorming, where they identify what they feel is high risk and then they list mitigations, but they're not necessarily going through in a consistent method in a repeatable way. So if another organization or another group even within the same organization were to look at that later, they don't necessarily have a clear understanding of what was discussed. Another really big gap that we've seen is for larger projects, having poor communication across organizations. So when you have multiple equipment suppliers and a lot of different engineering teams working on a large facility, it's important to have clear traceability of who's responsible for each step of the safety life cycle, and make sure that none of those steps are missed. And so trying to get all of that documented without formal management in place is very difficult, and it typically we've seen poor communication over it. Also, even for just operating facilities, understanding that there are a number of organizations responsible for providing support to the control system, also maintenance organizations, different things providing continued service, making sure that the functional safety expectations are clearly defined is very fundamental for that. Another big thing we see is missing or incomplete documentation. So even though they're maybe going through and doing those tasks, they don't have easily accessible or clear documentation. And this kind of ties back to not having the formal structured process, because that is, again, a case where when someone comes in to try to understand what's being done for functional safety, it's then harder to prove really all of the good work that is being done. And so that can be an issue sometimes. Also, kind of some of the things that we see from a technical perspective when looking at the SIS, sometimes non-SIL rated equipment without the proven in use justification, so equipment that hasn't had the systematic capability justified, is being used in safety systems. And this can be an issue because when going through and doing the calculations, it's very important to determine what the failure rate of that component is, and that's really based on the failure rate of the individual components within the equipment. But if the equipment is not designed following specific quality management procedures, or there's not sufficient operating experience for proven in use, there are other types of failures, potential deficiencies in the design or some sort of systematic failure that could defeat the safety system. And so not having justified equipment within the SIS is a gap that's often seen. Another potential problem is not including all of the components. So really, the safety instrumented system should include, what's done to detect the hazardous situation, the processing power that takes that input and then tells your output, whether it's the valve to close off flow, or the motor contactor that then stops the motor from running. So all of those components need to be considered. And if there are multiple actions that are required to achieve your safe state, then every action that's required really needs to be a part of the safety system. Another gap that we see are unrealistic modeling assumptions. And so kind of the best example for this is to think about the proof test coverage taken for a final element. And so sometimes we've seen things such as taking a 100% proof test coverage. But based on how valves works and the mechanics of it, this is an unrealistic expectation for a number of reasons. The first being that it really isn't possible to detect all of the failure modes with it. But even if you have someone who would dispute that argument, there's also the potential that the actual proof testing on the valve can cause a failure. So just for that, we know that we can't claim a 100% proof test coverage. And the problem with that and the other unrealistic modeling assumptions is it gives an overly optimistic estimate of how good the safety system is. And so because of that, we will still have residual risk. We're not really doing everything that needs to be done to mitigate the risk to the tolerable level. We also see incorrectly modeled shared equipment. So sometimes equipment can be leveraged both in the BPCS and then also if there's a secondary trip command from the SIS, this can give some additional credit. But it needs to be understood that there's not complete independence and there are kind of specific calculations that can be done to really document this correctly. But if full independence is assumed for some of the shared equipment, it again leads to overly optimistic failure rate calculations. When we look at really what can be done to fix these gaps, we also can see kind of some effective strategies that would go into mitigating a lot of these problems. And the first one is really having that clear functional safety management plan. And so following that would explicitly address kind of these first 4 requirements. So it gives you that formal process. It documents what the tolerable risks for the organization are. It ensures that the documentation for each life cycle step is completed and provides a clear expectation of what that documentation is. And then all of that together really helps to facilitate clear communication across organizations. Instead of trying to hit then a moving specification that from one conversation to the next might seem to be different, if you have a clear functional safety management plan that can be pointed to with specific requirements, this can really help to go through filling some of those gaps on the communication side. For the remainder of our issues, having group procedures, so specific procedures that are followed to go through and execute a safety lifecycle task, is fundamental for ensuring that you're able to meet those requirements. It provides the specific technical guidance for the policies and procedures that are followed while, say, executing your cell verification. So understanding what the boundaries of accepted proof test coverage would be, where your failure rate data comes from. All of these things are fundamental for ensuring that the task is then completed correctly, and they all fall within the overall umbrella of functional safety management. When we took a little bit more of a deeper look at what functional safety management objectives are and what the overall goals are, we can go through and start to look at them. So the first would be to get, again, that company safety culture. And so time and time again in industry, when we see these major accidents, it's typically a combination of multiple factors and multiple decisions that end up leading to this dangerous scenario where our incident occurs. And really the only way to try to protect against that is to have a really clear and well-defined company safety culture. And that helps us to then just avoid those scenarios of what's called, say, slipping into a failure. Additionally, having that safety planning, so a clear functional safety management plan, helps to then go through and document the requirements for the next steps. Having a well-defined roles and responsibilities, so understanding who's responsible for each life cycle step, kind of provides that added accountability. The requirements and then documentation of personnel competency ensures that you're able to show that the people completing the safety life cycle tasks have the necessary experience to go through and do that, and also provide confidence in the results they come out with. Looking at the documentation and also document control schemes, ensuring that for each lifecycle task, the necessary output is documented, it's findable, and really can be shown that those requirements are being met. Then looking at really functional safety verification activities, whether it's the functional safety assessments to kind of have that independent check that the life cycles have been completed, or periodic functional safety audits to make sure the process is continually improving. And then lastly, kind of referencing what the documented processes and procedures are for each of those individual life cycle tasks to give clear visibility. When we break down how this is achieved, we want to look at kind of the key functional safety documents and how they work together to achieve our overall functional safety management objectives. And so the first one is really the functional safety management plan, and that is our top level requirements. And so an example of what a top level requirements could be would be a description of what competency means, whether you're looking at 3 different layers of basic, practitioner, and expert. So having those formal requirements of what it takes to meet each of those levels. So providing those overall top-level requirements that then are applied to each individual process. It addresses all phases of the safety life cycle. So really, it just provides the high-level approach of the organization. So it'll include, what is done in the analysis phase, so the requirements for going through and doing a process hazard and risk assessment. What's done for documenting the safety requirement specification, and then all the way through the design, so the SIL verification, factory acceptance testing, implementation, and also then even to the operations and maintenance phase. So what the requirements are for proof testing, the maintenance requirements for the overall safety system, and how they ensure that the management of change procedure is followed. It includes a clear description of handoffs between not only the life cycle phases, but also groups. So groups, whether specific groups within the same organization or also within different organizations, having that clear traceability of who's responsible for which requirements helps to make sure that nothing falls through the cracks. And then lastly, the appendices can contain some useful reference information that would be looked at through the project. So whether it's definitions for functional safety, or if the company has specific definitions that are used during the risk assessment or layer of protection analysis, some of that can be documented in the overall functional safety management plan as a reference, so that if there are questions kind of with the technical content in subsequent documents, that there's a central reference that they can look at for key terms. And also, for example, providing what the SIL levels are that are being evaluated during the project. Then under that functional safety management plan, there's what's called a group procedure. And this is really a process description for the relevant phase, or even think of it as a relevant life cycle task. And so if we talk about, say, SIL verification, for example, the inputs required would be having a defined safety requirement specification, understanding the system design, so what components are going to be used within the SIS. And so then the process would say, based on this information, perform a SIL verification using Markov modeling, document what accepted sources of failure rates are, what typical assumptions are made, and really ensure that when going through and doing that SIL verification that you're following the robust procedure. And then finally, after going through it and completing the process, what then the required outputs are. So maybe having the SIL verification report and also having that documentation of the systematic capability for the components, whether that's the equipment certification or the proven in use documentation. So all of that would be covered within the group procedure. And then also under the functional safety management plan is the individual project plan. And this is for those larger organizations. It's really key for those bigger projects, tracking what the documentation is for each step within the project, who's responsible, what are they responsible for, when does it have to be delivered, how is it going to be stored, what's the procedure that's followed through. So all of that for each task is really important on these larger projects. And also having the necessary sign-offs. So making sure that each of these steps is independently reviewed and verified, that the appropriate people sign off their approval. When we look at specifically the FSMP and try to break down the individual components, we see again that there are these guidelines for all 3 life cycle phases, so analysis, design, operations, and maintenance. It defines the management of change procedures, and this is really key pretty much for every stage during the process. So as soon as that design is kind of documented, risk assessment is formed. From then on, management of change has to be followed to do impact analysis and understand what the effect of each change to the system is. And then it also calls out the functional safety assessment plan. And so this is really the strategy for going through and performing those periodic functional safety assessment audits, and also the functional safety assessments to document that all of the life cycle tasks up to that point have been completed correctly. And this is really required to be an independent senior person who has that experience to give a good cold eye review. And then the step and sequence of the work activity. So for each of those phases, for all of these activities, making sure that there are clear roles and responsibilities, the personnel competency requirements, the documentation structure, and the overall verification for each step is really the objective of that overall functional safety management plan. When we break down kind of the steps and sequence of the work activities further, we can look at the roles and responsibilities. So A, making sure that they're clearly delineated and communicated, and B, making sure that they're present for each phase of the safety lifecycle and all of those associated activities, really is the requirement for providing that overall roles and responsibilities. And it's specifically noted as one of the primary objectives for functional safety management. So it's specifically called out within the standard as a requirement. And so included on the slide here is a sample from the project safety plan template. And it's essentially documenting the RACI chart for determining who's responsible for each of these life cycle steps. So we've got different roles up top. So from the project manager to the lead safety engineer, the controls engineer, process engineer, and then documenting who's responsible for each specific task, who is held accountable for it, and then what roles would be consulted or informed about that task. So having clear documentation of that one individual responsible for each safety lifecycle task is really fundamental to ensuring that it does get completed. When we look at the documentation requirements, we're talking about what needs to be documented, but also all of the information that's needed to perform the safety life cycle. So pretty much when we're talking about the documentation requirements, you have to be able to clearly show that all of this information is available. So having the key information to perform each phase of the safety life cycle, the overall management of functional safety life cycle, as well as completing those verification and validation activities to ensure that the steps have been completed correctly, as well as then the requirements and results of the functional safety assessment. And so when we talk about documentation, there are kind of the 4 R's we like to talk about. So the first is having the right data, making sure that for each phase of the safety life cycle, all of the necessary input is there and defined, and that you have the correct technical information to pull. The next one is in the right format. So some of the big ones here are having text searchable documents, making sure that the documents follow a similar structure, so personnel are able to find the right information. They're able to go through and track the correct sections. Have it at the right time, so ensure that in the overall project life cycle that the documentation is available when it's required. So if you don't document the safety requirement specification until you've already gone through and done the design of the safety instrumented system, you really can't take advantage of having those clearly defined requirements, and it takes rework then to go back and ensure that all of those requirements are met. Whereas having them defined earlier in the project would avoid some of that iterative loop. And then having them in the right place. So making sure that the documents can be found by the people who need to access them, and that there's a clear and consistent document storage process. And then also looking at the competency requirements. And so in the newest version of the IEC 61511 standard, these requirements have been further enhanced. And so now, in addition to just requiring that the individuals are competent to carry out the life cycles for what the activities for which they are accountable, it's also requiring a specific list of items to be addressed and documented when considering the competency. So making sure that you have formal requirements for competency and that they're being documented and periodically assessed. And so really with that, a procedure must now be in place to manage the competency of all those involved in the SIS safety life cycle, and a periodic assessment of that competency is also now required. So that gives us an overview of really the key items within the functional safety management plan. Now we're going to look at really what goes into the implementation of this. And so kind of three of the keys are to leverage existing quality programs that are already in place, have the specific management and technical activities for each safety lifecycle phase, having that responsibilities of people, department, and organizations that we've talked about. And really the key ways to achieve this are having one or more person appointed to be a functional safety lead, extending what's currently looked at for the existing quality system, developing the specific functional safety lifecycle procedures, using templates to do that as needed, and also using the necessary tools to support the different functional safety lifecycle tasks. And then the last one, which is really a key for any effective implementation of really any management system, is the ability to plan, execute, audit, and improve. So having those functional safety audits defined and following that continuous improvement process to kind of have that successful implementation of the functional safety management. And so when we work with our customers, we've actually done a number of surveys to try to see what other trends are there when it comes to the adoption of these standards. And so one thing that we found interesting was the vast majority of those polled, over 70%, have said that they are adopting the IEC 61511 standard when it comes to functional safety. And when we go on to then ask how many of them have a functional safety management plan, we see that a little over 40% have formal functional safety management plan. Another 15 or so percent have included functional safety as part of the overall safety plan. So about 60% of those polled are implementing functional safety management, but a little less than 20% have maybe a semi-formal functional safety plan, and 20% have not specifically addressed functional safety. So still about 40% of the organizations don't have that formal functional safety management plan, and that makes it very difficult to successfully implement the IEC 61511 lifecycle. And so kind of as we go through and have done these gap assessments, it's been a request to us from our customers to say, how can you help us here? So we know that we have a gap. We want to start working on the functional safety management, but we just don't have the experience with it. Where do we get started? And that's really where the templates came in. They were developed kind of as a result of those conversations, trying to provide that guidance to help go through and implement the IEC 61511 lifecycle. And so we have a number of templates available at the exida web store, and really these go everything from functional safety management, so the FSMP plan, the project safety plan, the requirements for personnel competency, management of change. So those would be examples of procedures that fall under our functional safety management. And then we also have the group procedures for the different lifecycle phases. So from the analysis, design, verification, validation, and also the operations and maintenance. So having kind of that clear documentation in place for each of these life cycles. When we look at the full list of the functional safety management templates, essentially we're meeting all of the overall functional safety management requirements by having documents related to specific requirements. So we have our high-level functional safety management plan that provides our overall requirements. And then under that, we have, say, a project safety plan that will document the specific lifecycle tasks completed within a project. We have the competency evaluation procedure and competency log for really ensuring that that is periodically evaluated, and then also that there's clear documentation. The action item template, so what's done to ensure that say the action items generated within a safety lifecycle step are reviewed and completed. The functional safety assessment procedure, so what is done to periodically independently review the safety lifecycle tasks, functional safety audits for that continuous improvement, and then also management of change procedure and configuration management procedure to ensure that any changes made to the safety intermittent system or that could affect the system are well documented and considered. And then we also have a number of group procedures documenting some of the key lifecycle steps from hazard and risk assessment, LOPA, safety requirement specification, SIL verification, and then also to the operations and maintenance phase. So proof testing templates and the overall SIS maintenance plan. And so really the benefit of going through and using functional safety management plan templates are they give you a starting point for functional safety management. So, when we've gone through and identified those gaps, sometimes it can be daunting to try to go through it and really bring all of the functional safety management online and get it up to speed. But really having those templates as a starting point can help to make that process easier. And it really will lead to a decreased time and energy that's required to go through and implement the overall functional safety management. It can help you actually deploy functional safety and functional safety management more quickly. So really getting the requirements out there, starting to implement them, getting people used to actually using them. It ensures that all of the requirements of IEC 62511 are captured. So we've gone through all of the standard requirements, and for each safety lifecycle task, that individual procedure includes all of the requirements from the standard within it. So you can have confidence that when you go through and follow these procedures that you're following all of the requirements of IEC 62511. It includes additional best practices, so things that have been learned that really go through and build an effective implementation. And there's also these then do reference the existing quality management procedures, and so it gives you a benefit of, if you have ISO 9001 procedures in place, kind of leveraging that as your entry point for functional safety management. And then lastly, they're designed to be easy to use and give you consistent and uniform formatting for all of the procedures. So what I'm going to do now is just quickly scroll through the functional safety management plan template to show you what it looks like. This is a great time where if you've had questions throughout the presentation or anything that you want more specific information on, please type that question in now, and I'll do my best to, we'll take time and look through the questions after going through the template. Okay, so on my screen, I have our functional safety management plan template. A couple of things to highlight. It's really made to be company specific, so places are made for the individual's company's logo, and this can be updated and customized. Also, we've leveraged fields throughout the document, and so this feature allows you to update information in a central place. So if we go here to our properties and we want to update our fields, we can change the title of the document. We can go through and edit the subject, and so this will update each place in the document where this is used. It will give us kind of the updated text, and so this makes it a lot easier to go through and document all the company-specific information and really capture that as easily as possible. So I can just update that information here, and then when I go through and update the fields within the document, now we can see that all of this has changed. So we now have our updated title, updated company location, and then I can do the same thing in our header and footer. And again, so now we have our updated company, we have the author, and so all of that can be kind of easily done. The templates come with instructions, so we have a forward to a template that we say you can delete when actually using as your functional safety management plan. But it basically walks through the steps of what would be done to take this template and then build it into a company-specific procedure. We have the high-level management summary, and so this includes kind of the objectives for this system as well as example text. And so throughout the templates, example text is included in italics, just so that you can update it to meet the exact requirements for your organization, and then have that be company-specific text. Also, we reference other documents within the functional safety management plan, so it allows us to have clear communication of how the lifecycle tasks are related, and if we're looking at the overall functional safety management, having this plan in place plus the project safety plan then really gives you that combination. We can go through, each would have its own table of contents that can show the specific sections that are covered. We have the specific purpose and scope for each document, the reference document, so including the standards, and then also the related procedures, templates, and documentation within the specific company. And so these are, again, those other procedures that and other templates that are available. For our functional safety management, we have our high-level requirements, so looking at what's needed for the personnel responsibilities and competency, looking at what's required for the safety planning, understanding the specific scope definition, having that implementation and monitoring, so those periodic functional safety audits, periodic functional safety assessment, all of this really goes into having an effective functional safety management system. And then we also do have then the high-level requirements for each analysis phase and which life cycle steps are completed during those phases. And so in addition to having the kind of requirements for that step highlighted, we also have the individual steps, the input, the output, and the responsible party documented all in one table to provide a clear reference point. So this just kind of goes to show how the templates are, how they can be used to kind of really be a strong starting point for going through and then improving the functional safety management. And so we can go back just to the end of the presentation and address kind of any last minute questions that people have. So in summary, we went through and looked at what trends we're seeing in the adoption of functional safety, how functional safety management really plays a key role in the adoption and effective implementation of IEC 62151, and then lastly, we just did a quick look on how templates can be used to really jumpstart the application of functional safety management. If you're interested in learning more, my contact information is included on the slide, so please feel free to reach out to me in an email. The slides will be sent out after the presentation. Also, if you have interest in learning more about the gap assessment or benchmark, anything to do with functional safety management plan development or functional safety management templates, please feel free to reach out to me. We also have a number of upcoming training courses. The one that I do want to highlight if you're local to the Philadelphia area is we do have a one-day cybersecurity course coming up at the Philadelphia Navy Yard. It's a really cool location and we'll have kind of a lot of experts there. So this is a great opportunity if you're interested in learning a little bit more about cybersecurity. We also have a number of self-paced online training that can be a really good option, depending on your location, to have the flexibility to do it at a time that's convenient for you. So that's kind of information on how to follow all the latest from exida. And so now I'm going to take a chance to then go through and answer the questions that we had during our presentation. So let me expand this. Okay, sorry, I'm trying to get the questions pop up. I see we have a couple. Okay. This question is, the FSM document does include the SRS, and yes, so the safety requirement specification, we have a group procedure for that. So we have, the procedure that would be followed to go through and document the safety requirement specification. We've also included a template within that. So actually, a table format of where all those requirements can be kept. So then in addition to having that individual procedure, it is required and referenced within that overall functional safety management document. So that is kind of one of the key activities that is called out and looked at. Let's see. The other question here is kind of relating to personnel competency. And so, trying to define exactly what those requirements are can be subjective. And so they're asking then really, kind of what would be some general best practices for that, and also kind of what are some key areas for, making sure that competency is documented. And so what we've done in the templates is really using kind of 3 layers of competency. So having that basic layer, that practitioner layer, and that expert layer. And so for someone who has basic competency, they may have an understanding of the task being completed, and then they're able to then sit in on and be a part of that task. For someone leading the task, so say someone facilitating the risk assessment or layer of protection analysis, they may be required to be at least a practitioner. So having a set number of years of experience doing that task, have an understanding of the individual system or application, and then be able to go through and lead that activity. And then someone for an expert, this might be what's required more for, say, a functional safety assessment. So having that independent expert level to come in and do your cold eye review. For demonstrating that expert requirement, you might require that a specific personnel certification be in place. You might require, say, instead of a couple years of experience, 5 to 10 years of experience. And so having that as your specific personnel requirements for that expert level. And so by documenting those different tier levels, you're able really to fit it to the specific needs of that individual task, and that seems to give a good amount of flexibility. All right, so that was the 2 questions I see. So please feel free, if there are any further questions, to send them to me in an email. I will be sending up a Q&A based on the questions from this session and also the morning session. So all of those questions and answers will be provided with the slides. But again, so please feel free to reach out to me in email if you have any other questions. Thank you very much for joining for the webinar today. Please take care and enjoy the rest of your day.